Hello friends, welcome to all of you. Today we will see our next lecture of inorganic chemistry, in which we are going to see first paper coordination chemistry, and from that first unit metal ligand bonding. This is the content of our unit. From this content we have seen crystal field theory and splitting of d orbital in octahedral and tetrahedral complexes. Octahedral and tetrahedral complex we have already seen. Today we will see the splitting of d orbital for square planar, square pyramidal and trigonal bipyramidal complexes. Okay, first we will see square planar complexes. See carefully, this is the square planar complex. At the center there is a degenerate d orbitals, 5 d orbitals, and to that d orbitals 4 ligands. See, this is the ligand. These ligands are approaching to the d orbital of metal. Okay, the geometry of complexity is square planar, means 4 ligands are approaching, and these ligands are approaching along two Cartesian axes, x-axis and y-axis. 2 ligands from x-axis, 2 ligands from y-axis, and from z-axis there is no interaction of any ligand. See, this is the geometry of square planar complex. At the center there is a metal d orbital or metal, and 4 ligands are approached. Now this is the shapes of 5 degenerate d orbitals, which having two groups, T2G and EG. Okay, first 3 orbitals, these are from T2G, in which their orbits are present in between the axes, and last 2, these are the EG, where their orbits are present along the axis, dxy, dyz, dxz, T2G, and dx square minus y square and dz square. It is from EG. Now we'll see this actual splitting of d orbital. This is the energy bar where energy it is increased. First, it is a degenerate 5 d orbitals of central metal atom or ion. Due to the approaching ligands, there is a splitting of these 5 degenerate d orbitals into two groups in the octahedral field. It is like this. The energy of EG orbitals it is increased, and energy of T2G orbitals it is decreased. We have already seen. The EG orbitals these are the doubly degenerate and T2G triply degenerate, and this is the geometry. This is the general octahedral geometry. Now what we are going to do, we are going to remove the ligands from the z-axis. There are two ligands, one is at the top and another one at the bottom. We will remove these two ligands and we will see what will happen. Okay, when we removing these two ligands, see what is happen. There is a formation of tetragonal field or tetragonal geometry. Due to that, the doubly degenerate EG orbitals get again splitted into two groups. Why? Because we are removing the ligands from z-axis, means there will be less interaction, and due to that less interaction, the energy of dz squared orbital it will get decreased, and the ligands are approaching along the axis, and due to that x and y axis, due to that the energy of dx square minus y square it will get increased. Similarly happen for T2G. For T2G there are 3 orbitals, and from the 3 orbitals ligands are approaching from x and y axis, and we are expelling removing z axis. Therefore dxz and dyz orbitals their energy will be decreased, they will get doubly degenerate, and the energy of dxy it will increase. See, this is the tetragonal geometry. See, the distance in between z-axis ligands it is increased from the central metal. And at last we will see the square planar geometry, in which we will completely remove the z-axis ligands, two ligands. Due to that, what happening, the energy of dz square from EG orbital it will get completely decreased, and the energy of dxy orbital, it will be increased. See, this is the splitting of d orbital in square planar field, and this is the geometry. Very simple. Just we have to see some steps. First step, degenerate d orbital, then we'll go for octahedral, tetragonal, and at last square planar field. Okay. Now next complex or geometry we will see, it is a square pyramidal complex. See, this is the square pyramidal complex. It contains 5 ligands, 4 ligands from x and y axis, and only one ligand it is approaching from the z axis. This is the d orbital. So what will be the interaction? The ligands, these are approaching along the axis. Y-axis contains 2 ligands, x-axis contains 2 ligands, and z-axis contains only one ligand. Now what will happen for the interaction? The orbitals which are present along the axis, they will show more repulsion, means their energy will be increased, and the orbital which are present in between the axis, they will show less repulsion, therefore their energy will be decreased. These are the 5 d orbital shape, T2j and EG. Now we'll see the splitting of d orbital. See, this is the geometry. It is a square pyramidal. This is the energy bar. These are the 5 degenerate d orbitals of metal atom, and this is the splitting. Now see carefully. There are 4 ligands along the x and y axis. Therefore, the energy of dx square minus y square, it will be highest. Then one ligand, it is present along the z axis. Therefore, its energy will be at second position. Then from T2G orbit, in between the axis, dxy, and at last doubly degenerate dxz and dyz. This is the very simple square pyramidal field splitting of complex. Okay. Now next and last, we will see trigonal bipyramidal complex. See carefully the geometry. In this geometry, 3 ligands, these are present, this, and this. These are equatorial, and 2 ligands, this one and this one. These 2 ligands are axial. Okay, similarly, the bond angle in between equatorial 2 ligands, it is 120 degree. It is 120 degrees. Now what will happen? See the Cartesian axis, imagine. Okay, these are the Cartesian axis, x-axis, y-axis and z-axis. Along the z-axis there are 2 ligands, means no problem. But for x-axis and y-axis, if we take one ligand at the x-axis or y-axis, the other 2 ligands, they will not at the another axis. Why? Because the bond angle, it is 120. For square planar and square pyramidal, the bond angle, it is 90 degree. Therefore, ligands are present at the x-axis and y-axis. But in this case, only one ligand, it will attain only one axis. Either it will be x-axis or y-axis. Okay. Now we will see the splitting direct. This is the energy axis. These are the 5 degenerate d orbitals, and this is the splitting. The dz square orbital, it will show the more repulsion because along the z axis 2 ligands are approaching, therefore they will show more repulsion, and due to that its energy, it will be increased. For dxy, okay, dxy, it is from T2G orbit, and dx square minus y square, it is from EG orbit, EG group, sorry. These both will have similar energy, near about similar energy, and they get doubly degenerate. And the dxz and dyz, they will have less repulsion because these are present in between the axis and ligands are approaching along the axis, along the z axis. Okay, therefore what happens, they will experience less repulsion, therefore their energy it will be decreased. This is a very simple splitting of d orbital for trigonal bipyramidal complex or field. Okay, now we will see the all 5 complexes in one figure and their step by step splitting. For octahedral, see, this is for octahedral, then here it is tetrahedral. For octahedral it is EG and at the rest it is a T2G. For tetrahedral, top side it is T2, another one it is E. Then square planar, see square planar. For square planar, see this is the splitting of d orbital. Then tetragonal pyramidal or square pyramidal. For that purpose this is the splitting. And at last trigonal bipyramidal, at last we have seen this is the splitting. Okay, and here we finish our last point, splitting of d orbital for 5 geometries: octahedral, tetrahedral, square planar, square pyramidal or tetragonal pyramidal, and trigonal pyramidal. Also we have seen for tetragonal complexes. Okay, after that if you have any doubt you can write mail or comment at the bottom of this video. I will answer all your questions. Thank you very much. We will meet at our next lecture. Thank you.